Hi students, welcome to our physics class. In this class, I am going to explain new topic electricity, lesson number 8 in 10th class. Lesson name is electricity, current and electricity. Here, what is electricity? To know that electricity, before going to know electricity, we must know the concept about the charge. What is charge? Yes. In general, every body is made up of atoms. We studied in previous classes. Every substance or every body made up of atoms. In each atom, there are electrons, protons, neutrons present in each atom. We know that protons present in the nucleus, protons and neutrons present in the nucleus, that is middle of the atom, and electrons revolve around the nucleus. These all happening in the atom. So in atom there are electrons and protons and neutrons. Protons, neutrons present in the nucleus, middle of the atom, electrons revolve around the nucleus in the atom. So here, what is happening here? Every body in the nature is neutral. Why? No charge. Will not exhibit any charge. In our nature, generally any body is neutral. No charge exhibits. Why? Every body consists equal number of electrons and protons. Of course, neutrons no charge, so we can neglect them. So what about electrons and protons? The number of electrons and protons in every body, in every atom, number of electrons and protons are equal. So that is why the charge of atom is balanced with the positive charge and negative charge. We know that electrons are negative charge and protons have positive charge. Protons are positive particles, positive charged particles. Electrons are negative charged particles. So because of equal number of electrons and protons in the atom, the charge is balanced. So that is why what will happen? That atom exhibits neutral. That is why all the substances available in the nature generally neutral charge, exhibits a neutral charge. Then when the body gain charge, we know when you touch some bodies, we may get shock or we feel charge. Why? Bodies gain charge. Why? What is the reason? Because of transfer of electrons. Because of transfer of electrons. Example, we studied in previous classes. When we comb your hair, what will happen? There is a possibility of change of electrons one substance to other substance because of friction. Because of friction, there is a possibility change of electrons one substance to other substance. Hair to comb, electrons transfer because of friction. Some electrons air loses and comb gain. If you continuously comb your hair, then comb gain negative charge and hair gain positive charge. Why negative charge? Why positive charge? Already I told you, every body consists of equal number of electrons and protons. When transfer of electrons, that means electrons losing, the body gain positive charge because the power protons dominates. Electrons losing, protons dominates in the body. Then what will happen? That body exhibits positive charge. And now comb gains electrons due to friction. Comb gain electrons in this case. Then comb gain electrons. Then electron charge is negative charge. Then what will happen? In the comb, before that comb is neutral. When electrons are excess, then comb exhibits negative charge. So that is only charge. Then here two bodies gain charge. What is that? Hair and comb. Similarly, here as per concept of charge, transfer of electrons cause for the charge in the body. Transfer of electrons cause for charge in the body. Here, just now I told. Here electrons transfer one atom to other atom. So because of that, the transfer, when an atom loses electrons, what will happen? that atom gained positive charge. When atom receives electrons from other atoms, what will happen? That atom exhibits negative charge because of excess electrons cause for a negative charge, because of excess protons cause for a positive charge. Here transfer of electrons cause for charge. Yes, here see, what is the SI unit of charge? Coulomb. SI unit of charge, there is a unit for charge, Coulomb. What is the charge? SI unit of charge is Coulomb. Now you know that what is the charge of electrons? Uncharge of electron, uncharge of proton. Every electron have some charge, every proton have some charge. What is that? Here see, charge of electron is minus 1.6 into 10 power minus 19 coulombs. This is the charge of electrons. Even protons also have charge, same charge, equal charge. Just now I don't know, both have same charge in atom, equal number. That way both are balanced and neutral. So here, what is the electron charge here? 1.6 into 10 power minus 19 coulombs. Here a minus, why I have given here minus? To represent the negative charge. In case of protons, same value, but it is positive. Okay. Now, units for charge, coulomb. Units for charge is a coulomb. 1 coulomb charge, how many electrons present? See, 1 coulomb charge, how many electrons? Then this electron charge divided with the number of electrons. If you divide with one charge of electron to the total coulomb charge, 1 coulomb charge divided with each electron charge, then you will get number of electrons present in 1 coulomb charge. Similarly, we can find out 1 coulomb charge, how many electrons present here. If you calculate 1 coulomb charge divided with the electron charge, then number of electrons, what is the value? 6.25 into 10 power 18 electrons for present in 1 coulomb charge. We can calculate number of electrons per 1 coulomb charge. What is the meaning of this? In any conductor, number of electrons transfer, number of electrons taken place in 1 coulomb charge is 6.25 into 10 power 8 electrons. Okay, now next concept. What is the relation between charge and electricity or current? Yes, current. Symbol represented the symbol I, current I. What is the definition of current? Rate of flow of charge, rate of flow of discharge. Yeah. What is the meaning of rate? Just rate means what? The charge per rate of flow of charge. Meaning is the charge per unit time. The charge taken transfer per unit time is called rate of flow of charge. Rate of flow of charge is called current, represented with the symbol I. Here, I is equal to Q by T. What is the meaning of this? Q represents the charge. The symbol Q represents the charge and T represents time. Okay. Now, current is equal to, current in the conductor or current is equal to, here see, as per definition, rate of flow of charge. That means charge per unit time. Rate means the charge per time. So rate. So Q by T is equal to Q by T. T time, the flow of charge charge represents Q. For T time is called current. Current is Q by T. Now, current, units of current is amperes. Now, units of charge, coulombs. But symbol is Q, but units are coulombs. Now, units of time, seconds. These are SI units of current, amperes. SI unit is for charge coulombs. SI unit for time, seconds. Okay. So now 1 ampere is equal to, if you represents 1 ampere is equal to 1 coulomb charge flow for 1 second. 1 coulomb charge flow for 1 second is called 1 ampere current. 1 ampere current. Now if you see the diagram, see these are all atoms. This is one conductor. This is one conductor. Conductor means which allows flow of current. So every conductor consists of so many atoms. So many atoms. Every atom there are negative charge particles and positive charge particles. Because of electrons, here see how the charge will flow. Electrons flow from one atom to other atom. Electrons flow in one direction. If electrons flow in one direction, then what will happen? When electrons are flowing in one direction, those particles, those atoms gain positive charge. Electrons losing cause gaining of positive charge. That means electrons are moving in one direction, then those atoms are gaining positive charge. When electrons are losing cause gaining positive charge. Here losing electrons are moving in one direction because of battery. Because of battery. Battery give some energy. Battery gives some energy to the electrons to move in one direction. So because of that battery, electrons move in one direction in the atoms. Electrons flow. Then what will happen? These atoms, when electrons losing from the atoms, those atoms gain positive charge. Then positive charge flows in other direction. That is the inner happening in the conductor. Yes. Now, what is potential? What is the potential? Just now I told battery. Yeah, potential created by the battery. Here see potential. Potential means what? Here definition of the potential. Generally we use potential. We have potential to do some work. Yeah, that is only potential. Work done to carry charge. To carry the charge. To carry this charge in the conductor one place to another place, there is some energy is required. That is called energy, called work. The work done to carry charge electrons, to carry electrons one place to another place, some energy is required, that given by battery. So that is called potential. Work done to carry charge one place to another place is called potential. Its potential is represented with the symbol V. Then V is equal to work done to carry charge. We know symbol of work is W. Symbol of charge is Q. Here see, symbol of potential is V. V is equal to work done to carry charge. Now here see, work done V. What is the meaning of V? What is the units? What are the units of potential? Volts. Units of potential is volts. Is equal to units of work. SI units of work, joules. SI unit of charge, coulombs. So 1 volt is equal to joule for coulomb. Joule for coulomb. Now similar potential difference gives same meaning. Potential difference. Here the work done to carry charge between two places. Between two places, A to B. If you take 2 points in the conductor, one point A, one point B, then work done to carry charge, energy, required energy, work done nothing but required energy to carry charge one point to another point, A to B, then required energy is called potential difference. Potential difference means what? Work done to carry charge between 2 points. So that we can say here work done between potential difference VA minus VB. What is the meaning of this? Potential difference between 2 points A and B points. VA minus VB is equal to work done to carry charge between these 2 points. carry charge between these 2 points, work done to carry charge is equal to, so what units of work is joules, units of charge is coulombs. So here potential difference also represented with the volt. But then units of potential difference is volt. So volt, 1 volt is equal to 1 joule for 1 coulomb. So 1 volt potential difference is equal to 1 joule per coulomb. So such a way we can define potential difference. That's all for now. We will discuss remaining concept in next video.